So how exactly does fire happen? Fire is one of those phenomena that everyone knows exist, but few people know how exist. So let's get into the physics of fire. The chemical reaction that is fire converts fuel and oxygen into carbon dioxide and water. Because it's an exothermic reaction, it produces heat. This heat is produced because oxygen's chemical bonds are weak, and the new bonds that are produced are much more stable, making a new production of energy. The basic equation for fire is fuel plus oxygen into carbon dioxide plus water. However, combustion is much more complex than this. There are many other intermediate molecules involved while the fuel and oxygen turns into CO2 and water. On some occasions, incomplete combustion occurs, and these intermediate molecules are produced in very large quantities. For example, if a fire doesn't get enough oxygen to keep its flame, it will produce carbon monoxide, a compound dangerous to humans, rather than carbon dioxide. Flames are produced when two gases react and produce both light and heat. When they react, they produce different amounts of energy, which affects the temperature of the flame. Using pure oxygen rather than air, which has other elements and compounds, will produce a higher temperature. The composition of elements and compounds also changes the color of the flame. Orange flame is due to the presence of sodium, copper compounds transform into green or blue flame, lithium turns into red, and high oxygen fire burns blue. But obviously, making fire isn't as simple as putting oil outside and waiting for the response. You have to have something called an ignition temperature. The fuel, which to clarify can be oil, wood, alcohol, acetone, etc., has to be at or above a certain temperature to start decomposing and release gas. The exact temperature and exact process of reaction depends on the fuel, but let's use wood as an example. Wood has to be at 300 degrees Fahrenheit, 150 Celsius, for heat to decompose some cellulose material inside the wood. The cellulose is released as a gas we know as smoke, which is a compound of hydrogen, carbon, and oxygen. The rest of the material forms char and ash. When the gas gets to 500 Fahrenheit or 260 Celsius, the gas breaks apart and the atoms recombine with the oxygen in the atmosphere to form water, carbon dioxide, and other products. The dangerous thing about fire is that it's self-perpetuating. The heat of the flame itself keeps the fuel at the ignition temperature, so it continues to burn as long as there's fuel and oxygen around it. And we know that oxygen is almost everywhere. When the flame ignites the gases, the fire spreads. This is why putting a blanket on a fire commonly works. It cuts off the oxygen supply in the air, so the fire will die. So how come using water to put out fireworks? Water lowers the temperature at the burning substance, and when the temperature goes below the ignition temperature, the fire dies. This is the same way that wind can put out the fire, but it's less successful since wind can carry the fire onto other ignition resources like grass or another tree. But most of us have seen water burning on top of water. How is this possible? So this is an optical illusion. Usually the water isn't helping the fire burn, it's the oil on top of the water since oil is less dense than water. That pretty much sums up everything about the physics of fire. Keep in mind there's still quite a bit that is not covered in this video, but if everything was, this video would be way longer than it should be. Thanks for watching, and if you enjoyed it, please subscribe. Let us know your comments in the comments section below, and have a nice day.